guys, today we are going to watch this video. How does the space shuttle look? So we are just now gonna watch it.
In this video, I want to show you how they launched the space shuttle.
Okay.
We'll look at all the preparation beforehand, then the details of the launch pad, and then their 8.5-minute journey into space.
8.5 minutes. Ooh, nice intro.
Sadly, the space shuttle is retired. It no longer flies. However, I think it's still really important to learn about. After all, some of this technology is still being used for space programs. In preparation for this video, I read a few books. One of them was called Riding Rockets, and it was written by 3-time astronaut Mike Mullane. He does a good job of capturing what it was like to ride on the space shuttle. I reached out to Mike, and he was really helpful. He made a lot of good suggestions for what to include in this video. Though before we get too far, let's review. This is the orbiter vehicle, the part that looks like an airplane and carries the astronauts and payloads into space. I have a video all about
this thing also helped to build the ISS.
About the inside of the orbiter vehicle. I'll put a link in the video description down below. It takes so much fuel to get into space that we need a really big gas tank. That's what the orange external tank is for. It provides the fuel for the 3 space shuttle main engines. Even this isn't enough to launch us into space. We need 2 extra rockets on each side. These are called the solid rocket boosters, or SRBs. It takes a lot of work to get all of these pieces ready for the launch. There were 2 launch sites for the space shuttle: Kennedy Space Center in Florida and Vandenberg Air Force Base in California. Shuttle launches from the Vandenberg site ended up being canceled, and as a result, all 135 shuttle missions were launched out of Florida. So let's take a closer look at Kennedy Space Center in Florida. It has 2 launch pads, 39A and 39B. Shuttle missions were launched from both of these pads. There's a few buildings way over here, about 5 kilometers away from the pads. The large one here is the Vehicle Assembly Building, or VAB. It's as tall as a 38-story building. This is where they would assemble the space shuttle in preparation for a launch. Next to it is the Launch Control Center. Notice how it's positioned with a good view of both launch pads. This building is called the Orbiter Processing Facility, or OPF, and actually there were 3 OPF buildings. It's where the orbiter was serviced in between missions. Over here is the Shuttle Landing Facility. This is where a mission ends for the space shuttle. But they didn't always land here. Sometimes, due to weather or other circumstances, the shuttle would land in California at Edwards Air Force Base. When this happened, we need to get the orbiter vehicle all the way back to Florida, and the shuttle can't really take off again and fly like an airplane. It wasn't built for that. So here's what happened. The orbiter vehicle was taken to the Mate-Demate device, or MDD, which would lift up the shuttle and then load it on the back of a special airplane called the Shuttle Carrier Aircraft. It was then flown across the United States to get back to Kennedy Space Center in Florida.
Why does the plane look like the president's plane, man?
It was then taken to one of the OPFs. Once inside, the engineers would literally crawl all over it to fix or replace many of the shuttle components to make sure that it's safe to fly for the next shuttle mission. This process can take several months to complete. This is part of the reason why the space shuttle was so expensive. Meanwhile, work starts over here.
Shuttle missions take months to prepare.
Here at the VAB. We start with the solid rocket boosters, which are assembled piece by piece. On the inside is the solid rocket fuel. Once ignition starts at liftoff, it cannot be turned off. Now it's time to lift the external tank into place. Inside, there are 2 smaller tanks, one for liquid hydrogen and one for liquid oxygen. These tanks will remain empty until just a few hours before the launch. Now, at room temperature, hydrogen and oxygen are both gases, which take up an enormous amount of space. But if we put them at extremely cold temperatures, they will turn into liquids, and we can put a lot more fuel inside of the tanks. The liquids from each tank will flow through pipes down to where it will connect to the orbiter. This side is for the liquid hydrogen, and this side is for the liquid oxygen. Once the orbiter was ready, it was then transferred from the OPF to the VAB. This was referred to as a rollover.
Why can't they just
The
use
orbiter
the
was then
wheels,
hooked up to a
man?
crane and then
Oh,
carefully
yeah,
lifted up,
controlling it.
moved over to the high bay, and then mounted to the side of the external tank.
Oh, that's cool.
The fuel and electrical connections are attached to the bottom of the orbiter. There is also another attachment point up towards the top.
The space shuttle is
Once this is all ready to go, we need to move it to one of the launch pads, which are more than 5 kilometers away. This is referred to as the rollout.
Oh, okay.
The weight of the entire shuttle stack is supported at the base by 8 hold-down posts, 4 on each of the SRBs. It's then secured in place by the hold-down bolts. At the moment of liftoff, these will detonate to free the shuttle.
I'm so stupid.
The platform it's on is called the Mobile Launch Platform. Underneath is the crawler transporter, which moves everything at just under 1.5 kilometers per hour. It takes many hours to get all the way to one of the 2 launch pads.
I could walk next to that.
Then it's up the ramp and slowly into position. The platform is put down on supports.
Oh, supports. Okay.
And the crawler goes back down the ramp.
Crawler, you don't have to carry so much weight anymore. But thanks for
the mobile launch platform has large holes for the rocket flames.
Cool.
The 3 main engine flames will go through this hole.
Yeah. All rockets are cool.
And the flames from the 2 SRBs will go through these 2 holes.
Oh, yeah.
Below the pad is the flame trench. During the liftoff, the flames will be deflected to each side.
Oh yeah, they just need.
The structure next to the shuttle stack has 2 main parts.
Okay.
The fixed service structure, which doesn't move, and the rotating service structure, which can pivot around to completely enclose the space shuttle.
This thing. Yes.
Sometimes the payloads were loaded here in the vertical position.
Okay.
And other times they were loaded before this, when the orbiter was on the ground at the OPF.
Okay.
The fixed service structure has a lightning mast on top, and then 3 service arms. 2 of them are vent arms, which will collect excess hydrogen and oxygen from the external tank. This is the gaseous hydrogen vent arm, with the ground umbilical carrier plate at the very end. At the top is the gaseous oxygen vent arm. Because the fuels are so cold, the beanie cap is really important to prevent ice buildup at the very top. The third arm is called the orbiter access arm. At the end of it is the white room. This is how the astronauts get on board the orbiter in preparation for a launch. Down here are the 2 tail service masts. They have connections to each side of the orbiter. On the day of the launch, this is where the fuel will come in to fill the orange external tank.
I am right.
If there is an emergency on the launch pad and the astronauts need to get away in a hurry, they will come over here to the emergency egress system. It has several baskets that can quickly carry them far away from the launch tower. Each basket can hold 3 people. One more feature of the mobile launch platform is the sound suppression system. Beginning at just a few seconds before launch, water will start pouring out from a few different places. This will limit the sound shockwaves from bouncing back up and damaging parts of the space shuttle as it leaves the ground.
Can I drink the water?
The water is stored in this large tower on the launch pad. So let's see how this works on the day of the launch. There are many things that have to happen in order. I can't cover them all in this video, but let me show you some of the main ones. At T-minus 5 hours and 35 minutes before the launch, fuel begins loading into the external tank. The fuel comes from the white spherical tanks on the edges of the launch pad. Remember that the SRBs already have their solid fuel inside of them. At T-minus 3 hours, the astronauts leave for the launch pad and begin to enter the orbiter vehicle. Since the shuttle is vertical on the launch pad, all of the seats are in the laid-back position. Most missions had 7 astronauts, 3 in the middeck and 4 in the flight deck. There are no windows on the middeck, so some of the astronauts won't be able to enjoy the view on the way up.
It's the big 2026, so don't say that is in the big 2026.
There's a lot of excitement coming up to the moment of liftoff. However, if there are any problems, such as mechanical failures or even bad weather, then the launch will be delayed or even canceled until another day. This is called a launch scrub, and it can happen all the way up until just a few seconds before liftoff. At T-minus 7 minutes and 30 seconds, the orbiter access arm is slowly retracted. If there is an emergency, they can quickly bring it back into place. At T-minus 3 minutes and 45 seconds, main engine gimbal test to make sure that it's working correctly. T-minus 2 minutes and 55 seconds, the beanie cap is lifted and the gaseous oxygen vent arm is retracted. At T-minus 10 seconds, activate the hydrogen burn-off system. And no, this does not actually start the engines. That happens up here inside of the combustion chamber. What these sparks do is ignite any excess hydrogen. This hydrogen can cause an unexpected explosion at launch if it isn't taken care of. At T-minus 6.6 seconds, the 3 main engines ignite. All 3 of them must work correctly or they will shut down and abort the launch. At the moment of liftoff, many things happen simultaneously. The gaseous hydrogen vent arm is retracted from the external tank. The 2 connections at the tail service mast will retract. The 8 hold-down bolts will detonate, which frees the shuttle, and then both SRBs ignite. For their journey into space, the shuttle is mostly flown by the autopilot. Of course, the astronauts can still take over if they need to. Shortly after clearing the tower, they do what's called the roll program to get the shuttle so that it's heads down for most of the ascent into space. This reduces the aerodynamic stress on the wings. It will also allow the astronauts to see the curve of the Earth as they ascend into space. Now, as we keep gaining more and more speed, the air in the atmosphere will create pressure on the front of the spacecraft. Then as we get higher, the air starts to thin out. They use the term max Q to refer to the time when the aerodynamic pressure will be at its highest. During max Q, the main engines will be throttled down, so we don't accelerate too quickly, but then shortly after, we can throttle them back up again. A little more than 2 minutes after liftoff, the 2 SRBs have done their job. They are detached, and then small rocket motors on the bottom and on the top fire on each booster to ensure that they are separated from the vehicle. The SRBs fall back down to the Earth where they will parachute in for a soft landing in the ocean. They will be recovered by boat and then refurbished for a future shuttle mission. Now the 3 main engines are on their own. As we get higher, more and more fuel will be used up from the external tank. This means that the shuttle will keep getting lighter. We have to keep throttling down the engines or we'll accelerate too quickly. The maximum amount of acceleration we want the astronauts to feel is 3 Gs, or 3 times the force of gravity pushing them into their seats. At about 8 minutes and 30 seconds, we have main engine cutoff, or MECO. This must happen before the tanks run dry so that the engines aren't damaged. The external tank is now detached. We're not in orbit yet, so the tank will head back down to Earth and burn up in the atmosphere.
Burns up over the Indian Ocean. Okay.
The 2 doors on the bottom side of the shuttle will close now that the external tank is gone. If they didn't close, we would have gaps in the heat shield at the end of the mission, which would not be so good. At this point, the orbiter vehicle is on the same path as the external tank. We're not quite going fast enough to stay in orbit around the Earth. Remember that the external tank had the fuel for the 3 space shuttle main engines, so we can't really use these anymore. Instead, we'll use the 2 OMS rocket motors. These each carry their own fuel inside of the pod.
About to end.
This gives us that last push into orbit around the Earth. Now it's traveling at 28,000
You guys already seen my space shuttle, no? Yeah.
kilometers per hour, many times faster than the speed of a bullet.
Not realistic.
Now it's time to do some science,
Spacewalk.
release a satellite,
Hubble! What's up?
or dock to the International Space Station.
Oh, nice. So yeah, that's gonna be the end of the video. Bye.